Now we're moving on to look at just integration, and generally not trig specific. So back to ordinary functions just in terms of x, and the instruction will be for this type of integration question will be to use substitution, and the substitution that you're to use will be given. So it should be really easy to identify these sorts of questions. So straight from the syllabus it says that you will be able to undertake some harder integration questions. For example, find the integral of x root 1 plus x squared dx. Now normally we'd look at that, and because it's got a square root there, we know we can't simplify, we can't expand the x into that bracket. And so just considering we've got the integral of a product, we go, well, then that's something we don't or haven't learned how to integrate. However, that question goes on to importantly say, using the substitution u equals x squared plus 1. So, like I said, really easy to identify. The only difference between 1 and 2 is now we're talking about definite integrals. So we've actually got limits on our integral, and we know about the answer to that will be a number. So as opposed to the answer to this will be an expression. Okay, so there's nothing specific about u. You might see somewhere they say use v or use w, any letter really. However, u is really common. So what we will end up doing is integrate an expression just in terms of u. So we can't have x's in it. We'll be integrating a u function, and obviously we'll be integrating with respect to u. So we'll get a du in it. So this dx here has to get replaced with a du. Now, there's just a little technique, and you think, well, there's nothing much to that. If we just think about that idea, we're going to replace dx with du. If you think about dx, all the different ways you could write dx. Dx could be written, and we want to get a du in there, as du times dx, that's an x, du. Now, is that correct? Is dx equal to du times dx du? Of course it is. That and that goes. Dx is dx. So what would be the advantage of writing a du times dx du? Well, one, this gets included into our integral. So if we had straight out the integral of dx, so we could write that as the integral of du times dx du. Now this is really good. We're integrating with respect to u, and we need a du in it. So that's going to stay. But what about dx du? What is dx du? Well, have a think about it. Integrating x with respect to u is, we could turn this around. We could get this in terms of x by calling this u minus 1, or the square root of u minus 1. And we could then differentiate x with respect to u. So this will be possible, and you'll see how that unfolds. So basically that is it. We will transform our integral into the pronumeral, the function in terms of u, and we'll clearly be needing to integrate with respect to u. With the definite integrals, now when it's written like this, a and b here refer to the x limits. And when we're integrating some function with respect to u, these two have to be u values. So they'll no longer be a and b, But we will work out what u is worth when x is a, and that will go here. And we will work out what u value we would get when x is b. So you can think about that. B, putting a number in there for x, we'd be able to work out what u needs to be in that top position. Okay, hopefully that's not too confusing, and we'll get on with some examples. Just before we do look at the examples, I want to talk to you about some techniques. So just like I was introducing this little technique here, there are other little techniques that you will need to use, and they really come from just observations about what you've got. Now, just think about for a minute, just separate yourself from this U concept for a minute, just to establish some techniques. You're familiar with dy dx, and we can treat dy dx as a fraction, where dy is the numerator and dx is the denominator. And that allows for some interesting manipulations. And it's not just with y and x, it could be like u and x, or etc. But let's just go with dy dx because we're really familiar with that. If, for example, you knew that dy dx was equal to 2, what are some things, all we're doing here, not specific to substitution, integration by substitution, just in general, what are some other ways that you could write this? Dy dx is equal to 2. Well, you know that you could multiply both sides by dx, and you end up with an expression for dy. Dy is 2 times dx. Or you could end up with an expression for dx. Make dx the subject, divide both sides by 2, and you get dy on 2. Why am I talking about these sorts of things? Because there's going to be times when we will have information like this, and we might want an expression for dy, or we might want an expression for dx. Just keep it in mind. This is where they actually come from. If you knew, for example, that dy dx was 2x, what if we wanted an expression just about dy? Well, we could say dy is, multiply both sides by dx, 2x times dx. Or we could say 2x is dy over, dx is dy over 2x. Now, that, it says, wouldn't be commonly used. Could you see that you wouldn't be mixing up y's and still keeping an x in it? Yeah, that would be pretty unusual when you get the combinations of y's and x's. X times dx would be dy on 2, and that could be really helpful. So what are we doing here? We're just going from here and dividing both sides by 2, x times dx, and you might have a situation where you recognise this, and you could replace it with dy on 2. Don't forget, this is not so much a technique, it's a little integration rule, that if you've got the integral of a constant times a function, you can take the constant out the front, and that constant could also be a fraction. So sometimes it's nice to get the fractions out. It's not so complicated. The other little rule I would remind you of is that a to b of f of x is minus b to a of f of x. Now, we'll see that we're going to need to change the values of our limits when we're doing definite integrals. And if you find that when you change the values, you're not going from smaller number to bigger number, then you might swap it around and put it with the smaller number down here and the bigger number up there, but you will have to put a negative out the front. So, good observation skills are essential. And realise now that we'll be talking about du. But we could have been talking about dy du or dx du. in these previous explanations. Actually, I might just stop the video there and do the actual examples and talk about the steps in another video.